All right, we're in Chapter 16, and the subject of 16 is Microprocessors and Computers. Microprocessors serve as the brains of a computer. A microprocessor is made up of nearly all of the digital circuits previously studied, and I would say plus more. It is an integrated chip comprised of flip-flops, gates, and so forth, with the power to replace many other integrated circuits. We will look at microprocessors in general. We're not going to look at specifics, and we'll discuss vocabulary. An advanced course will spend an entire quarter examining microprocessor theory. So if this is an area of interest for you, you may want to consider taking the advanced course and spend an entire quarter examining microprocessor theory, and in that particular course they will examine a very specific processor. Okay, basic concepts and terminology. Essentially, a microprocessor can be considered to be notice a high-speed instruction set executor. The microprocessor is given a list of things to do, and that is instructions, and it executes or carries out those instructions. And this term right here is a symbol your text uses to represent microprocessors. So this is the symbol micro with a capital P, and so your text will use that as a shorthand way to express microprocessor. Instruction set. Every microprocessor has a certain set of instructions that it is capable of executing. This group of instructions is referred to as its instruction set. Each type of microprocessor will have its own instruction set it can interpret and execute. Intel, AMD, and others have developed most of the instruction sets in use today. And if you go out on the internet and search on these terms, RISC and CISC, this is for reduced instruction set computer, and this is for complex instruction set computers, you'll find lengthy discussions and theory addressing instruction sets. Okay, typical instructions, and these are just representative of a few of the many instructions you would find in an instruction set. So here is an instruction for adding, and this instruction would say add one number to another. An instruction for move, this would move a number from one storage location to another. Increment, this would increase the value of a counter by 1. Decrement would decrease the value of a counter by 1. And then shift left or right, this has to do with shifting all the bits in a binary number one position to the left or to the right. So if we had a 1, 2, 3, 4, 1, 0, 0, 0, here we have this would be a binary 8, and if we shifted this to the right, then we would have something like this. And if we had shifted this to the left, we would have had something like this. So that'd be shifting right, shifting left. Just as a side note, this is equivalent to multiplying or dividing respectively the original number by 2. And so what you might note here is if you hit, here we have 8. If we shift 1 to the right, then it becomes 4. If we'd have shifted to the left, it becomes 16. So anyway, kind of a side note. But these are examples of typical instructions. Programs. Instructions arranged in a particular sequence are called programs, and this is a whole other area. Software and building using programs like Visual Basic and whatnot. Software engineering. We're not going there, but I'm just mentioning that. The microprocessor executes the programs sequentially. Programs can be anything from a word processor to a thermostatic control to a cell phone, calculator, etc. Anyway, list is endless, and this would address the whole area of software. Memory. Memory is necessary in a microprocessor or computer system to store the program. The specific memory type is dependent upon the particular application. And terms, there's a term called a byte, and we've talked about that in earlier chapters. A byte is 8 bits. And there's another term called a word. This typically is referring to 2 bytes, but word sizes can be expanded to 32, 64, and other sizes depending on the bus size. For purpose of simplicity, we will limit our discussion to single byte machines. Some applications require a few hundred bytes of memory, while others require many megabytes. And you might, if you had a calculator, for example, it may just, you might just need a few hundred bytes of storage, while, a PC might require many megabytes. In today's machines, many of them are using a gigabyte of RAM. Okay, memory. If we're using a small 8-bit machine, we would have 2 to the 8th would give us 256 potential instructions. And the idea is that we have 1, 2, 3, 4, 5, 6, 7, 8. That would be 0, and then 1, 2, 3, 4, 5, 6, 7, 8. This would be 255. And between 0 and 255, we have 256 values, and each of those could represent an instruction. So if we have an 8-bit machine, it could have a potential of 256 instructions. And here we have a couple of examples of potential instructions. Here we have 0011, 0011. This could mean add, and this value here could mean subtract, but we're giving these specific binary values. They're attaching a command to those so that the computer knows that when this specific binary value is executed, it's giving an instruction to do a specific task. Memory needs are determined by the size of the program and the size of the associated data, and it could be, several hundred bytes to many megabytes. Okay, we have begun our discussion on microprocessors. We've looked briefly at memory, programs, instruction sets, and we will conclude with that.